Data science is the most demanded domain. But did you ever think why it's getting the popularity? Let me tell you why data science is getting the popularity. Because we have lots of data right now with us. Each and every moment we are actually making our data. To process those unstructured or semi-structured data, we need a proper way or proper process. And that's what data science comes into the picture. Data science has lots of tools and machine learning and deep learning algorithms which help us to process those unstructured data. And if you also want to make your career in data science, there are some parts you need to know properly when you go for any data science interview questions. To keep that in mind, we came up with a tutorial, the data science interview question. But before start the video, please subscribe Great Learning to get updated with the new videos like this. And if you want to do courses on this domains as well, then go to Great Learning Academy where you will get almost 80 plus free courses. And after complete your course, you can claim your certificate as well. And if you want to do this courses in your mobile application, that is also possible using Great Learning app. So don't miss the opportunity, use as much as you can. And let's get started with the tutorial. In this tutorial, we will have a look at what is data science. Then we will jump into why do we need data science and what is the life cycle of data science. Then we will have a look at some of the most used interview questions. If you are an AI enthusiast or if you want to prepare your career for data science, then I should suggest you to go for full video. It will help you to understand what are the critical questions you have to face when you go for any interview questions. Right? So let's get started. So first we will have a look at why do we need data science. Before give the example why do we need data science, let me give you a real time scenario that why data science becoming so popular these days. So in the past what we used to have data which are in a structured manner and the amount of the data is less. But with time we can see that our data is becoming unstructured or semi-structured. So, and the amount of data become massive. So in this case, we need some of the tool which can handle this massive amount of unstructured or semi-structured data. And those data actually can be used to get a proper business insights and the hidden pattern from them. So when I'm talking about any hidden pattern, what are those hidden pattern, right? So let me give you a real-time example. For that you can understand what type of a hidden pattern I am talking about. Suppose we are going for a online society, right? So all the time whatever we are going to, like maybe we are going to go for buying a food or maybe you are going to book a cab, right? That time we use online transactions or online app booking facilities. So in that case, did you ever think that you are giving a data to these companies and they are capturing those data, but this data's amount is a huge amount, but they don't have a proper structured format. So this is how this massive amount of data give you a proper business insights. But before getting those insights, you need to actually pre-process them. And coming to the hidden patterns. So basically, when we go for any online transaction, we know that there are multiple transactions, they are fraud. But how can you understand that those transactions are a fraud transaction? In this case, we need to go for analyzing our data. Maybe there are some attributes they are related to that fraud transaction. So if you go for checking those data, if we go for analyzing those data, we will get this hidden patterns to understand that what are the attributes actually directly connected with the fraud transaction. So this is why each and every company right now are using their data to get a proper insight for their business. But processing those huge number of data using the traditional tool is not possible. So for that, we go for data science applications. Now let's have a look at what actually data science stands for. So data science is basically a process. It's not a single task to do, is a whole proper process to get some meaningful information from the massive amount of data. In simple terms, read and study the data to get proper intuitive insights. Data science is a mixture of various tools, algorithms, machine learning and deep learning concepts to discover hidden patterns from the raw and unstructured data. Now let's have a look at what is the life cycle of a data science. So when we come to life cycle, the basic part of a data science is you need to understand the business problem. So being a data scientist, they maximum used to interact with the stakeholders to understand the business problems. Okay, so first when you understand the business problem, that you after that you can go for basically going for objectives, right? What objective you need to go for. Then comes the data acquisition part. What is data acquisition? Data acquisition is basically stands for collecting the data. If you don't have data, how can you analyze them, right? So one of the main basic part of analyzing, collecting the data. So collecting the data is one of the main part. After you collect your data, we all know those data as unstructured or semi-structured data. Then we go for cleaning those data. After we clean our data, but this process is one of the most time consuming process because it takes a lot time to clean those unstructured data. Maybe you have misspelled attributes, maybe you have some unrelevant. So data cleaning is one of the most time consuming part because maybe you will have a misspelled attribute, some unknown data, some irrelevant data, right? They are not at all helping you to do the analyzing part, right? So in this case, data cleaning is most time consuming part. Then comes the exploratory data analysis. So what is exploratory data analysis? So exploratory data analysis is basically when your data is ready, when your data is structured, that time you can use some statistical concepts. So those statistical concepts helps you to understand your data. What is the spread of your data? Right? What are the outlier of your data? What your data actually consists of? What are the attributes? They are really correlated to each other. So this is why we use exploratory data analysis part. Now, when you have a proper idea, end-to-end idea about your data, that time you are quite sure that which algorithm you should go for to analyze your data, right? So that time we use machine learning techniques. So after doing the machine learning techniques, after making your model with the data using those machine learning algorithm, then we go for predicting our model. But why do we need prediction? Because maybe you give a data to your model, which your data actually the training data set, right? But after your training, you see there is a nice accuracy you got from your model. But when you are giving an unknown data to your model is failed to capture, to understand those data. So that means your model is not ready to go for with the prediction part, right? So prediction is one of the most important part when we are making the model. When you see that after giving a unknown data to your model as well, your model is quite working quite fine with that time you can say, okay, your model is ready. Now you can deploy your model to the cloud. For that, someone can use your model. So this is the whole scenario or whole life cycle of a data science. Now let's have a look at what are the tools we used for data science. So these are the basic tools I'm talking about over here, but there are multiple tools we have in data science. We have SQL to managing the database. We have Informatica, Python, Java, MATLAB, SAS, R. These are the basic tools when we talk about any data science languages, right? Now let's have a look at the interview question, what you can actually expect when you go for any interview for a data scientist, right? So first question is how to handle missing value imputation for quantitative values. So this is the part of again exploratory data analysis when you are actually handling your unstructured data. So basically there are four options we have. Maybe replace them with mean, replace them with mode, replace them with median, or none of the them. So your answer will be over here that replace them with mean, right? Now let's have a look at the second question. How will you compare two quantitative variables? So your answer will be, we can compare them using correlation. Change of any one variable can affect the other variable, and it can be done in scatter or dot plots graphically. So we use scatter plot or dot plots basically to understand and to visualize your data. Now let's have a look at the third question. What is DER model and what are the methods dependent on it? So what is DER stands for? So basically DER is decision estimation rank. So decision is basically stand for to decide like yes or no, risky or not, is not risky. Estimation is basically how much and when the variable are estimated, and rank stands for ranking them accordingly. Priority is what is more risky. Statistical techniques, machine learning and advanced analytics techniques are dependent on the DER model. Now let's have a look at what is forward regression. So forward regression is one of the automated mechanism of model selection. It starts with a variable and keep on adding variable till it reaches threshold. Now let's have a look at what is stepwise regression. So it is one of the automated mechanism of model selection that it starts with a variable and to some point it starts dropping variables. So these are the two types of regression we see so far. Now let's have a look at what is VIF and in what range it varies, right? So VIF stands for variance inflation factor, and VIF assess whether factors are correlated to each other, that is multicollinearity, which could affect p-values and the model isn't going to be as reliable. If VIF is greater than 10, problem of multicollinearity occurs, right? So this is how we actually go for using VIF, that is variance inflation factor. Now let's have a look at what is Fisher exact test. So Fisher's exact test is a statistical significance test used in analysis of contingency tables. Although in practice it is employed when sample sizes are small, it is valid for all sample sizes. Now let's have a look at what is correlation and what are its measures. So basically correlation is a process to measure whether two variables are related or not. Scatter plot is the graphical way of representing the relationship. Measures of correlation like strength of relationship and Pearson's correlation. Now let's have a look at what are the types of simple and multiple regression. This is one of the most important question when you go for any interview. So what is simple regression? So in simple regression we have two parts. One is linear and one is non-linear. And under linear we have continuous and linear regression. And in non-linear we have Poisson, logistic, multinomial, ordinal regression. And when we come for multiple regression, we have linear and non-linear. Now let's have a look at what do you mean by mean squared error. So basically mean squared error measures the average of square of the errors. That is average squared difference between the estimated values and the actual values. Now we came to the 11th number question. Is R square goodness of fit? So what will be your answer? R square is a goodness of fit measure for linear regression models. So this statistic indicates the percentage of variance in the dependent variable that the independent variables explaining collectively. For instance, small R square values are not always a problem and high R square values are not necessarily good. So this is how we can see the R square is basically goodness of fit. Now let's have a look at what is the difference between RMSE and R squared in statistics. So RMSE is the square root of the variance of the residuals. It indicates the absolute fit of the model to the data, how close the observed data points are to the model's predicted value. Whereas R squared is a relative measure of fit. RMSE is an absolute measure of fit. In addition, adjusted R square more than 0.75 is a good value for showing accuracy. In some cases, an adjusted R square of 0.4 or more is acceptable as well. Now comes the what are the state of art techniques in pattern recognition and machine learning. The two fundamental problems in machine learning are statistical analysis and algorithm design. The formal tell us the principle of mathematical models that we establish from the observation data. The latter defines the condition on which implementation of data models and dataset rely. On the basis of the survey, pattern recognition techniques can be categorized into 6 parts. This includes statistical techniques, structural techniques, template matching, neural network approach, fuzzy model, and hybrid models. Now let's go to the next question. What is the difference between general linear models and generalized linear models? Now we will have a look at what is general linear model. So general linear model is a special case of general linear model. And generalized linear model is an extension of general linear model. This is quite tricky, right? So basically general linear model is a special case of general linear model, but Generalized linear model is an extension of general linear model. In general linear model, response variable need to be continuous. But in the case of generalized linear model, response variable can also be categorical like yes or no, right? In general linear model, distribution of residuals is expected to be normal. But in the case of generalized linear model, distribution of residuals can be non-normal, that is like binomial for logist models. Now we will see the link function is a simple identity function like f of z equals to z for general linear model. But in the case of generalized linear model, include a link function that releases the mean of responses to the linear combination of predictors in the model like logic function, inverse function, etc. And the least square method is used to estimate the parameters of the model in the case of general linear model. And for generalized linear model, least square method is used to estimate the parameters of the model. So both the cases, the least square model is used basically to estimate the parameters of the model. Now let's have a look at what are the best application of linear regression. So basically, linear regression can be used to optimize the business process. But before going into the answer, let me tell you what is a regression. So regression is basically finding out a relationship between two variables. So let me give you an example that what actually want to mean by that. Suppose sales of ice cream is decreasing in the season of winter, but when we have a season summer season, that time sales of ice cream is increasing. So we can say there is a direct relation between season and the ice cream sale. To establish those relationship between these two variables, we need to use our algorithm. So that time we go for using maybe linear regression or some other algorithms, right? So this is actually stands for regression. So now let's have a look at what's the best application of linear regression. So already we said that linear regression can be used to optimize a business problem. Suppose a baker and estimate the right temperature for its oven to increase the shelf life of its cookies. Or maybe in VPOs or KPOs, we can analyze the relationship between the wait times of caller and the number of complaints. Or maybe we can take some other example like imagine you want to estimate the demand of your customer or you want to predict the sales of a particular items in the future. That time also we can go for linear regression. Or the last example can be insurance companies rely heavily on regression to understand the number of claims at any given time. Popular use of polynomial regression. So these are the use case or business application of linear regression. Now let's have a look at what are the assumptions of linear regression. This is one of the most asked question for an interviewer. So what are the assumptions we have for linear regression? The regression model is linear in parameters. The mean of residuals is 0. Homoscedasticity of residuals or equal variance. No autocorrelation of residuals. The x variables and the residuals are uncorrelated. The number of observations must be greater than number of x. The variability in x values in positive. The regression models is correctly specified. So these are the assumptions we need to take when we go for linear regression technique. Now let's have a look at what are the consequences of violating linear regression assumptions. So if you are going to violate the linear regression assumption, what will be the consequence? Whenever we violate any of the linear regression assumption, the regression coefficient produced by OLS will be either biased or variance of the estimate will be increased. So this is the problem you are going to face when you are going to violate the linear regression assumption. Now let's have a look at what are the limitations of linear regression modeling in data analysis. So linear regression modeling is one of the ways of specifying cause-effect relationship and predictive relationship in the data analysis. Variation in the data, both dependent and independent variable, it requires enough variation in the data. Assumption of deterministic independent variables independent of random error. This assumption is applied in many types of regression techniques. These are the limitations of linear regression modeling in the data analysis. Now let's have a look at how is least square different from linear regression analysis. So in linear regression is the task. fitting a straight line to the data, whereas the least square is the objective or cost function used to complete the task. Find the straight line that minimizes the sum of square of the residuals. These are the other cost function that could be used to fit the straight line. Minimize sum of the absolute error, for example. So this is how least square is different from linear regression analysis. Now let's have a look at how is hypothesis testing used in linear regression. So hypothesis testing in linear regression can be used for following reasons. If statistics can be used to check whether the parameters of the linear regression equation are equal to 0 or not. That is, whether the model is appropriate or not. T-test can be used to check the significance of the individual parameters. Other methods like forward selection or backward selection also use hypothesis testing for selecting the variables. So this is how hypothesis testing are used in linear regression. Now we will have a look at, can we use categorical values in linear regression? Yes, we can, but you must use dummy variables. Suppose you have a categorical variable with k levels. You would assign a categorical variable in -1 levels. For example, suppose the categorical value is gender, which has 2 levels. Then you would have a single categorical variable. You then define 2 levels with a binary variable. It will have a value of 0 if the subject gender is male. If the subject is female, we assign the value 1. This is properly depend on you that you want to, if you want to make gender male equals to 1, you can go for it, and if you want to make female equals to 0, you can go for it. It's up to you. In this case, the base case is males. The regression coefficient of the categorical variable is the difference in the mean marginal score between females and males. Now let's have a look at what are the advantages and disadvantages of linear regression. So linear regression is an extremely simple method. It is very easy and intuitive to use and understand. A person with only the knowledge of high school mathematics can understand and use it. In addition, it works in the most of the cases. Even it does not feed the data exactly. We can use it to find the nature of the relationship between two variables. What is the disadvantages of linear regression? By its definition, linear regression only models relationship between dependent and independent variable that are linear. It assumes there is a straight line relationship between them, which is incorrect sometimes. Linear regression is very sensitive to the anomalies in the data, or you can say it's an outlier of the data. Another disadvantage is that we have a number of parameters than the number of samples available. Then the model starts to model the noise rather than the relationship between the variable. So these are the advantages and disadvantages we have when we go for linear regression. Now let's have a look at what's really linear regression slope formula. For example, for some simple linear regression, given x that the random variable and y the response that dependent variable, the slope estimate is given by the ratio of covariance between x and y by the variance of x. So in the formula we can see covariance of x and y divided by variance of x. This is how we are going to calculate the regression slope. Now let's have a look at why logistic regression considered a linear model, right? So logistic regression is considered a generalized linear model because the outcome always depends on the sum of the input and parameters. Or in the other words, output cannot depend on the product or quotient, etc. of its parameter. Logistic regression is one of the basic and popular algorithms to solve a classification problem. It is named as logistic regression because its underlying technique is quite the same as linear regression. The term logistic is taken from the logit function that is used in the method of classification. And I want to add one more thing for logistic regression. Always logistic regression work with a discrete value, right? So when your data set is a discrete data set, that time you should go for logistic regression. But when your data set is a continuous data set, you should prefer to go with linear regression. Now let's have a look at what are the advantages of logistic regression. So logistic regression performs well when the dataset is linearly separable. Logistic regression is less prone to overfitting. But what is overfitting? So let me give you an example of overfitting. When your model works fine with the training data, maybe you will get a high accuracy when you are using training data set to your model. But when you are giving a unknown data to your model starts giving a very bad accuracy. But why does it happen? Because your model does not learn from the data. It starts reminding your data. This is known as the overfitting of the model. So this regression, this logistic regression is very less prone to overfitting, but it also can overfit in high dimensional data set. You should consider regularization, that is L1 and L2 techniques, to avoid overfitting in these scenarios. Logistic regression not only give a measure of how relevant a predictor, that is a coefficient size it, but it's also direction of association, positive or negative. Logistic regression is easier to implement, interpret and very efficient to train. Now let's have a look at what are the disadvantages of logistic regression we have. So main limitations of logistic regression is the assumption of linearity between dependent variable and the independent variable. In the real world, the data is rarely linearly separable. Most of the time, data would be jumbled mess. If the number of observations are lesser than the number of features, logistic regression should not be used. Otherwise, it may lead to overfit. Logistic regression can only be used to predict discrete functions. Therefore, the independent variable of logistic regression is restricted to the discrete number set. This restriction itself is problematic as it is prohibited to the prediction of continuous data. So these are the disadvantages we have for logistic regression. Now let's have a look at how do you interpret concordance in logistic regression. In case of logistic regression, we may fix our cutoff value. However, for the calculation of the concordance, we do not fix the cutoff value. Concordance gives an idea about the reliability of logistic regression. Thought it is not sufficient to rely solely on it. What it does, it takes every 1-0 pairs from the actual data, assuming binary logistic regression, and checks all the cases where the model has thrown a probability for 1 greater than the probability for a 0. Higher the concordance percent, better the model is. Now let's have a look at what's the difference between logit and logistic regression. The logit is a transformation, logistic regression is a regression model. The logit transformation transfer on lines to logistic curve. Logistic regression fits a logistic curve to set of data where the dependent variable can only take the values 0 and 1. It can be generalized to fitting ordinal data. Now let's have a look at what does the bias term represent in logistic regression. So in logistic regression, the predictors are assumed to have a linear relationship with the log odds of the success outcome. For example, if beta 1 in equation above is 3, then the log odd would be increased by 3 on average for each increase in 1 unit of x1. To see what the bias term beta 0 represents, simply set all xi to 0. The resulting log odds in the bias term. In other words, the bias term is the default log odds for the case of all predictors equals 0 or equal to reference value for categorical predictors. So this is what a bias term represents in logistic regression. Now let's have a look at, so is there an error term in logistic regression? Yes, 2 error terms can be defined for logistic regression. One, log loss or cross entry, which is equal to negative or maximum likelihood. You can use the output of the logistic regression to classify the data and compute the classification error of the model. You can use either of them, but the second one is more meaningful. Why is collinearity a problem for logistic regression? So basically, multicollinearity is a common problem when estimating linear or generalized linear models, including logistic regression and cost function. It occurs when there are high correlation among predictors, variables, leading to unreliable and unstable estimates of regression coefficients. Now let's have a look at what is C parameter in logistic regression. The trade-off parameter of logistic regression that determines the strength of regularization is called C, and higher values of C correspond to less regularization, where we can specify the regularization function. C is actually the inverse of regularization strength lambda. Now let's have a look at how is predictive modeling used in logistic regression. So logistic regression is a predictive modeling algorithm that is used when the y variable is binary categorical. That is, it can take only two values like 1 or 0. The goal is to determine a mathematical equation that can be used to predict the probability of event 1. Now let's have a look at which feature selection methods are better in logistic regression. The benefit of logistic regression is that it is parametric and has regression coefficients. You could then use L1 or L2 regularization. This penalizes more features with non-zero coefficients. L1 takes the absolute sum of coefficients while L2 takes the square sum of weights. L2 penalizes higher weights, so meaning it encourages more features with similar coefficients, whereas L1 could have a skewed set of coefficients a few higher and meaning lower. Now let's have a look at why is logistic regression so important for machine learning. Because logistic regression is the building block of machine learning and deep learning. Understanding it should be a first step of anyone who is starting their journey in data science. In machine learning, it is used for binary classification task. The logistic function f of x is equals to 1 by 1 plus exponential of minus x squishes the input and returns an output which is between 0 and 1. Hence, it gives the probability of a sample belonging to a particular class. Now let's have a look at, does scikit-learn support ordinal logistic regression? Yes, run an ordinal logistic regression like a multimodal ridge regression using MORD scikit-learn library. Now let's have a look at how can you improve the precision and recall of a logistic regression model. Improving precision and recall are the next step after trying multiple models. The purpose of precision and recall is not to be used to improve a model, but to evaluate one. The model with better parameterization will usually have better precision and recall. If you can train with less bias and variance, you will have better precision and recall and thus better F1 score, their harmonic mean. Now let's have a look at what is log likelihood in logistic regression. It is the sum of the likelihood residuals at record level. The natural log of error that residual is calculated for each record, multiplied by -1, and those values are totaled. The total is when used as a bias for deviance 2 into L1 and likelihood exponential of L1. The same calculation can be applied to a naive model that assumes absolutely no predictive power and a saturated model assuming perfect predictions. The likelihood values are used to compare different models, while the deviances test naive and saturated can be used to determine the predictive power and accuracy. With logistic regression, accuracy of the model will always be 100% for the development dataset, but that is not the case once a model applied to another dataset. Now let's have a look at how do you evaluate a logistic regression model. So first comes the model evaluation. Model evaluation is a very important part in any analysis to answer the following questions. How well does the model feed the data? Which predictors are most important? Are the predictors accurate? So the following are the criterion to assess the model performance. First, AIC. In simple terms, AIC estimates the relative amount of transformation lost by a given model. So the less information lost, the higher the quality of the model. Therefore, we always prefer model with minimum AIC. Now comes the ROC curve, receiver operating characteristics. So ROC curve illustrates the diagnosis ability of a binary classifier. It is calculated and created by plotting true positive against false positive at various threshold settings. The performance matrix of ROC curve is AUC, area under curve. Higher the area under the curve, better the prediction power of the model. Now comes the confusion matrix. In order to find out how well the model does in predicting the target variable, we use a confusion matrix or classification rate. It is nothing but a tabular representation of actual versus predicted value, which help us to find the accuracy of the model. Now let's have a look at what is the difference between neural network and logistic regression. So neural network and logistic regression are different techniques or algorithms to do the same thing, classification of data. Logistic regression is a statistical approach while neural network mimics the brain's neural network concept. When we use sigmoid activation function in neural network, it behaves like logistic regression. Does logistic regression require independent variables to be normal distributed? No, you can get the theoretical guarantees on model performance for logistic regression without any assumption on the distribution of the variables. However, LR is typically trained using stochastic gradient descent and does benefit from normalizing the variables to have the same standard deviation. Otherwise, SGD can take much longer to train. That might be what paper is referring to when they say LR requires normality for the continuous variables. Now let's have a look at how do I deal with missing data when running a logistic regression. Lot of data, maybe greater than thousands of data points. It's safer to ignore if it's really only 10% than to do anything else or use random forest or something instead of logistic regression. Moderate data, thousands of data points. There are several simple methods for missing data imputation and they will work reasonably given only a small portion of your data is affected. Small data, for small data set where it's going to be hard to learn anything from, I would consider either choosing a more advanced method that deals with the problem of missing data or to actually build a model based on some sort of domain knowledge or assumptions. Now let's have a look at what is SVM. So SVM stands for Support Vector Machine. It is a supervised machine learning algorithm that is used for both classification and regression problem. However, it is mostly preferred for classification problems. It can solve both linear and non-linear problems and work well for many practical problems. Now let's have a look at write some real-life application of SVM. So the most used real-life application of SVM will be face detection from a video or image, text classification, speech recognition, bioinformatics. These are the most used real-life application of SVM. Now let's have a look at what are the advantages of SVM algorithms. So SVM algorithm has basically advantages in terms of complexity. First, I would like to clear that both logistic regression as well as SVM can form non-linear decision surface and can be coupled with the kernel trick. If logistic regression can be coupled with kernel, then why to use SVM? SVM is found to have better performance practically in most cases. SVM is computationally cheaper, that O n square into k, whereas k is number of support vectors and support vector are those points that lie on the class margin, whereas logistic regression is O n to the power q. So the classification of SVM depends only on a subset of points. Since we need to maximize distance between closest points of two classes, that is aka margin, we need to care about only a subset of points, unlike logistic regression. Now let's have a look at which is the best kernel for SVM and why. It is a homogeneous, meaning that is only depends on the magnitude or relative distance between elements. That's not true for linear kernel. It is universal kernel, so it has some good approximate capabilities. particularly for support vector machine, consistency of support vector machine and other regularized kernel classifier. The bandwidth of the kernel is very easy to set with a cross validation, and in general there is also a good amount of literature for finding an automatic value. Now let's have a look at why does execute performs better than SVM. First reason is the execute is an ensemble method. It is used many trees to take a decision, so it gains power by repeating itself. SVM is a linear separator. When data is linearly separable, SVM needs a kernel to project the data into space where it can separate it. There lies its greatest strength and weakness. By being able to project data into a high dimensional space, SVM can find a linear separation for almost any data. But at the same time, it needs to use a kernel, and we can argue that there is no perfect kernel for every data set, right? So this is why execute perform better than SVM. Now let's have a look at what is a multi-class SVM method. So SVM are inherently two-class classifier that requires full labeling of data are directly applied to the two classes available, but for the real-life problems which require multiple classes, cause the problems and to rectify it. Multi-class SVM is used as it solves the problem as it forms multiple of two classes. Multi-class SVMs, MCSVM, are usually implemented by combining several binary SVMs. Now let's have a look at how does a SVM choose its support vectors. Choosing a support vector depends upon the type of data that needs to be classified. For example, for linearly separable case, for two-class separable training dataset, there are lots of possible linear separators. Intuitively, a decision boundary drawn in the middle of void between data items of the data of the two classes seems better than one which approaches very close to example of one or both classes. The SVM in the particular defines the criterion to be looking for a decision surface that is maximally far away from any data point. Now we came to the 15th number of question, that what is the disadvantages of structural SVM. So disadvantages of SVM algorithm is not suitable for large data set. SVM does not perform very well when the data set has more noise. That is, target classes are overlapping. In cases where number of features for each data point exceeds the number of training data sample, the SVM will underperform. Now we will have a look at the what is the best way to train a SVM on a very large data set. If you are dealing with a truly large data set that cannot fit in memory, then consider using SGD. But what is SGD? Stochastic gradient descent. When combined with approximate kernel methods like Nierstein method, you can have the benefits of non-linear decision boundaries while maintaining the scalability, right? So this is how you can actually handle the large data set to train a SVM. Now let's have a look at what is the difference between the perceptron learning algorithm and SVM. So basically, perceptron is an online algorithm, which means it can process the data points on one by one. On the other hand, SVM needs all the training data and only then starts building the classifier. If you look at carefully, the perceptron algorithm tries to reduce error and thus gives a good enough classification for the data points. However, since SVM looks at maximizing the margin by reducing half into theta to the power square, allows you to find the most optimal solution. Thus, SVM can help you to classify the test data in a better way, as a large margin can help you segregate it better. Maximizing of the margin can be done by simple techniques such as adding a offset. So this is the difference between perceptron learning algorithm and SVM. Now let's have a look at what is the difference between SVM rank and SVR. So what is SVR? Support vector regression. One is used for ranking and other one is used for regression. From the name itself we can understand that. There is a crucial difference between regression and ranking. In regression, the absolute value is crucial. A real number is predicted. But in the case of ranking, the only thing of concern is the ordering of a set of examples. We only want to know which example has the highest rank, which one has the second highest, and so on. From the data, we only know that example I should be ranked higher than the example 2, which in turn should be ranked higher than example 3, and so on. We do not know by how much example 1 is ranked higher than example 2, or whether this difference is bigger than the difference between example 2 and 3. So this is the basic difference between rank and regression, and from there itself we can understand what is the difference between SVM rank and SVR, right? Now let's have a look at how many kinds of SVM algorithm actually exist. So regularization penalty, that is soft margin and hard margin, from of the objective function, but it would not really be an SVM anymore, just some kind of a sparse kernel machine. From of kernel function, too many to list, modification for key greater than 2 classes, 1 versus the rest, 1 versus 1. Now let's have a look at what is the difference between the normal soft margin SVM and SVM with a linear kernel. So let's first start with hard margin. You have the basic SVM, hard margin. This assumes that the data is very well behaved and you can find a perfect classifier which will have zero error on training data. Now comes the soft margin. So soft margin basically stands for data is usually not well behaved. So SVM hard margin may not have solution at all. So we allow for a little bit of error on some points so that training error will not be zero. But average error over all the points is minimized. Now comes the kernels. The above assumes that the base classifier is a straight line. But what is not a straight line? It is a circle. Inside circle is one class, outside is another class. If we are able to map the data into higher dimension, the higher dimension may give us a straight line. Now let's have a look at how is linear classifier relevant to SVM. And SVM is a type of linear classifier. If you don't mix with kernels, it's arguably the most simple type of linear classifier. Linear classifier all learn linear fictions from your data that map your input to scores like so. Score is equals to Wx plus B, where W is a matrix of learned weights, B is a learned bias vector that shifts your score, and X is your input data. This is a type of function may look familiar to you if you remember y equals to mx plus b from high school. A typical SVM loss function, the function that tells you how good your calculate scores are in relation to the correct levels, would be hinge loss. It takes the forms loss is equals to sum over all score except the correct score of max. That is 0 score minus scores correct class plus 1. So this is how we can say how linear classifier relevant to SVM, because both of the cases we are using the same formula, that is y equals to mx plus b or wx plus b. Now let's have a look at, is one class SVM is really unsupervised? Yes, one class SVM is indeed unsupervised as there are no label data provided to the model. It can be considered as an outlier detection algorithm. Now let's have a look at how can you choose the parameter C for SVM. C parameter in SVM is penalty parameter of the error term. You can consider it as the degree of correct classification that the algorithm has to meet or the degree of optimization the SVM has to meet. For greater values of C, there is no way that SVM optimizer can misclarify any single point. Yes, as you said, the tolerance of SVM optimizer is high for higher values of C. But for smaller C, SVM optimizer is allowed at least some degree of freedom so as to meet the best hyperplane. Now let's have a look at, in layman's term, how does naive Bayes work. Bayes theorem is a mathematical theorem where we use existing data to predict what the outcome of a certain event will be for a given set of conditions. Now comes the naive Bayes algorithm. So naive Bayes is a simple technique for constructing classifier and models that assign class levels to problem instances, represented as vector of feature values, where the class levels are drawn from some finite set. It is not a single algorithm for training such classifier, but a family of algorithms based on common principle. All naive Bayes classifiers assume that the value of particular feature is independent of the value of any other feature given the class variable. Now let's have a look at why naive Bayes is called naive. Is it truly naive? Naive Bayes machine learning algorithm is considered naive because the assumptions the algorithm makes are virtually impossible to find in real-life data. Conditional probability is calculated as pure product of individual probabilities of components. This means that the algorithm assumes the presence or absence of a specific feature of a class is not related to the presence or absence of any other features. Absolute independence of features given the class variable. So this is why we call naive Bayes is really naive. Now let's have a look at what are the advantages of using a naive Bayes for classification. It is very simple, easy to implement and fast. If the NB, that is a naive Bayes conditional independence assumptions holds, then it will coverage quicker than discriminative models like logistic regression. Even if the naive Bayes assumptions does not hold, it works great in practice. Need less training data, highly scalable, it scales linearly with the number of predictors and data points. Can be used for both binary and multi-class classification problem. Can make probabilistic prediction, handles continuous and discrete data, not sensitive to irrelevant features. Now let's have a look at, are Gaussian naive Bayes the same as binomial naive Bayes? No, but binomial naive Bayes, it assumes that all our features are binary such that they can take only two values. Means zeros can represent what does not occur in the document as and ones as what occur in the documents. Then what is Gaussian naive Bayes? Gaussian naive Bayes is because of the assumption of the normal distribution. Gaussian naive Bayes is used in case when all our features are continuous. For example, in iris dataset, features are sepal width, sepal length, petal length. So, its features can have different values in dataset as width and length can vary. We can't represent features in terms of their occurrence. This means data is continuous, hence we use Gaussian naive Bayes here. Now let's have a look at what is the difference between the naive Bayes classifier and Bayes classifier. Naive Bayes assumes conditional independence that Px given y and z equals to Px given z, right? Again, Px given y comma z equals to Px given z. Again, Px given y comma z equals to Px given z. Whereas more general Bayes made, sometimes called Bayesian belief networks, will allow the user to specify which attributes are in fact conditionally independent. For the Bayesian network as a classifier, the features are selected based on some scoring functions, like Bayesian scoring function and minimal description length. The two are equivalent in theory to each other, given that there are enough training data. The scoring functions mainly restrict the structure, connections and directions, and the parameters likelihood using the data. After the structure has been learned, the class is only determined by the nodes in the Markov blanket, its parents, its child, and the parents of its children, and all variables given the Markov blanket are discarded. Now let's have a look at it, what real-world application is naive Bayes classifier used. Some of the real-world examples are to mark an email as spam or not spam, right? So we all familiar with Google automatically makes our emails in a spam folder, right? So did you ever think how it's gonna happen? So basically based on some of the keywords, Google understand using naive Bayes classifier that these mails can be a spam mails. So this is how they handle their spam mails. Classifies a news article about technology, politics or sports, right? The genre of the news. Check a piece of a text expressing positive emotion or negative emotions. Also used for face recognition softwares. Now let's have a look at, is naive bias supervised or unsupervised? First, naive bias is not one algorithm but a family of algorithms that inherits the following attributes like discriminant functions, probabilistic generative models, Bayesian theorem, naive assumption of independence and equal importance of features vectors. Moreover, it is a special type of supervised learning algorithm that could do simultaneous multi-class predictions as depicted by standing topics in many news apps. Since there are generative models based upon the assumption of the random variable mapping of each feature vector, this may even be classified as Gaussian naive bias or multinomial naive bias or Bernoulli's naive bias, etc. When is naive bias better than logistic regression? Naive bias also assumes that the features are conditionally independent. Real datasets are never perfectly independent, but they can be close. In short, naive bias has a higher bias but lower variance compared to logistic regression. If the dataset follows the bias, then naive bias will be a better classifier. Now let's have a look at, is naive bias a good algorithm for image classification? It can be done, but convolutional neural network are the state-of-the-art models for this task, particularly if you have a large amount of dataset. So basically, CNN comes under neural network, and this is one of the most used image classification algorithm. Now let's have a look at which one is better, naive bias algorithm or decision tree. Although it depends on the problem you are solving, but some general advantages are for naive bias work well with small dataset compared to DT, which need more data. The DT is basically the decision tree. Lesser overfitting, I already explained what is overfitting, smaller in size and faster in processing. Now comes the decision tree. Decision trees are very flexible, easy to understand and easy to debug. No preprocessing or transformation of features required. Prone to overfitting, this is a default, this is not a good thing about decision tree, but you can use a pruning or random forest to avoid that. You can use these techniques to avoid the overfitting part of the decision tree. Now let's come into the next question. Why naive bias a decent classifier but a bad estimator? The naive bias classifier produces competitive classification accuracy, but pretty inaccurate data point minus class level association probability estimates. The naive bias classifier conditional independence assumptions, namely the assumption that features are independent of one another, where conditions upon class level is rarely accurate. Features are often depend on one another non-trivial amounts, meaning multiple features often contain similar signals. However, the naive bias classifiers conditional independence assumptions result in the treatment of feature as distinct signals, each of which should independently contribute additional confidence to the classifier's prediction. This phenomenon amplifies the contribution of signal to the ultimate classification confidence. The naive bias classifier nonetheless produces competitive classification accuracy because the extent to which the independence assumptions favors different class levels, roughly even out on average. Now let's have a look at, why is logistic regression more likely to overfit than naive bias? With naive bias, the optimal value for each parameter is set independently. In other words, the features act very selfishly, each choosing its parameter for the sole benefit of itself, with no regards to what's best overall. The features don't cooperate. Logistic regression, on the other hand, sets all the parameters jointly, allowing for taking into account possible correlation between features. This gives logistic regression more expressive power or capacity compared to naive bias, and is precisely why the former can be more prone to overfitting than the latter. Now let's have a look at what types of dataset are appropriate for naive Bayes. When you have a plenty of input features but small number of records, then naive Bayes is a good approach. Actually, any machine learning algorithms with a high bias can be used in such a case. Naive bias is that the features are conditionally independent. Sometimes this bias is too much though. Make sure that the features are pairwise uncorrelated. Overfitting of the repeated or correlated feature leads naive Bayes to modest results. So I hope this question or answer really will help you to clear your data science interview part. And if you want to get more content like this, then please go to Great Learning Academy platform where we will get almost 80 plus free courses, and after complete your course you can claim your certificate as well. And if you want to do that courses in your mobile application, that is also possible using Great Learning app. And please subscribe Great Learning channel and do like and comment the video, for that you can get update for next videos as well. So now we come to when and why is a naive Bayes classifier is a better or worse choice than a random forest classifier. So random forest, it's a robust against overfitting, at least with my experiences and claims of the creator Leo Brainman and Adley Coulter. It is influenced by the AdaBoost. It gives better result with the increasing number of examples. It might be used for clustering, statistical inference and feature selection as well. Now comes the naive Bayes. Easy to train and understand the result. It has different extensions for different needs. Its model is smaller than the random forest since you need to keep all the trees in memory. Promising result for textual tasks. Now let's have a look at why are the algorithms naive Bayes and logistic regression considered so similar. So naive Bayes also assumes that the features are conditionally independent. Both naive Bayes and logistic regression are linear classification. Logistic regression makes a prediction for the probability using a direct functional from, whereas naive Bayes figures out how the data are generated given the results. Now we will have a look at what is decision tree. Decision tree is a supervised learning method used for classification and regression. It is a tree which helps us by assisting us in decision making. Decision tree builds classification or regression model in the form of a tree structure. It breaks down a dataset into smaller and smaller subsets, and simultaneously decision tree is incrementally developed. The final tree is a tree with decision nodes and leaf nodes. A decision node has two or more branches. Leaf node represents a classification or decision. We cannot do more split on leaf nodes. Now let's have a look at what are the advantages of using a decision tree for classification. A decision tree offers many advantages over other machine learning algorithms. We will understand this one by one. Addressing non-linearity. A tree-like structure helps it understand non-linear relation in the data very easily. At each step, it calculates the change in entropy in the dependent variable caused by each of the independent variables, and then splits using the variable causing the highest change in entropy. Now comes capable of handling both continuous and categorical variables. They are able to deal with both continuous and categorical dependent variables. However, that are more preferred for classification problem. Minimal requirement of data preprocessing. Compared to other algorithms, decision trees require less effort for data preparation during preprocessing. Decision trees do not require normalization and scaling of data. Due to its tree-based structure and method of splitting, it treats each of the variable equally without the requirement of normalization. Missing values in the data also does not affect the process of building decision tree to any considerable extent. Now we will have a look at how do decision trees for regression work. The most common method for constructing regression tree is CURT, that is classification and regression tree methodology, which is also known as recursion partitioning. A decision tree is a supervised machine learning algorithm. As the name goes, it is a tree-like structure with its root node on the top. This algorithm is one of the most popular techniques used for both classification and regression tree, that is CURT task. Mostly it is used for classification and it does not work that well for regression problem. Now let's have a look at what are some advantages of using a random forest over a decision tree given that a decision tree is simpler. Random forest overcomes several problems with decision trees including reduction is overfitting. By averaging several trees, there is a significantly lower risk of overfitting. Less variance. By using multiple trees, you reduce the chances of stumbling across a classifier that doesn't perform well because of the relationship between the train and test data. As a consequence, in almost all cases, random forests are more accurate than decision trees. Now let's have a look at what is an intuitive explanation of a decision tree. Yes, the decision tree algorithm is actually very simple. One of the simplest machine learning algorithm, perhaps only nearest neighbor is simpler. All decision tree algorithms have the same structure. Basically, it's a greedy divide-conquer algorithm. Take the entire dataset as an input. 2. Search for split to maximize the separation of the classes. A split is any test that divides the data into 2, that is if attributes 5 less than 10. Apply the split to the input data, the divide step into 2 parts. Reapply steps 1 and 2 to each sides of the split. The recursive conquer step. Stop when you meet some stopping criteria. Optional, that clean up the tree in case you went too far doing splits, called pruning. Now let's have a look at when is the random forest better than decision tree. With that said, random forests are a strong modeling techniques and much more robust than a single decision tree. They aggregate many decision trees to limit overfitting as well as error due to bias, therefore yield useful result. Random forests consist of multiple single trees, each based on random sample of the training data. They are typically more accurate than single decision trees. The following figure shows the decision tree boundary becomes more accurate and stable as more trees are added. Now let's have a look at how do you construct a decision tree. So decision trees for customer service play an important role to overcome challenges of knowledge. By providing decision trees to their support representatives and integrating them with the websites and self-care apps, companies can largely enhance their customer service level. So what will be the benefits of decision trees? Consistency of resolutions, enhanced first call resolution, that FCO, decreased average handling time, that is AHT, high customer satisfaction, that CSAT rate, and supercharged customer experience. Now let's have a look at how do you random forest and boosted decision tree compare. The prediction power of random forest over decision tree or regression tree mostly lies in the bootstrap sampling. In both example and features during training and ensemble average in the end. The first was also adopted in stochastic gradient boosting. The second has its pros, that parallel, and cons, that is less efficient sampling compared to boosting. Now let's have a look at why do people use gradient boosted decision trees to do feature transform. So this gradient boosted decision trees are robust against overfitting, don't need to rescale their data, can handle categorical variables, at least some can handle multi-model data with spikes, and that is first, right? The one thing the GBM and all trees are bad at is dealing with variables that have a relationship with each other. That is, if you plot two input variables and look at the space they need to split, they tend to make a lot of rectilinear staircase divisions to split two classes. Now let's have a look at why can decision trees handle unbalanced data for classification. While decision trees and boosting work better with unbalanced data, I wouldn't say decision trees are immune to unbalanced data sets. They may be able to handle them better, but it depends a lot on how the 1% are distributed. For example, if the 1% are all in one area of the feature space, it will do well. They will all end up in one node in the decision tree. If there are in 20 areas, then each area will represent 0.05% of the data and the decision tree will interpret it as noise. Now let's have a look at what's the best tool or software to draw a decision tree. There are a number of tools available to draw a decision tree, but best for you depends upon your needs. The main challenge in front of business today is to deliver quick and precise resolutions to their customers. Simultaneously, they have to ensure an easy understanding of knowledge and process for their support representative for efficient resolution delivery. Decision trees for customer service play an important role to overcome challenges of knowledge findability. By providing decision trees to their support representatives and integrating them with websites and self-care apps, companies can largely enhance their customer service level. Now let's have a look at, can decision trees implement both supervised and unsupervised learning? Decision tree implements supervised learning in a natural way. Almost all examples we see online implement supervised learning. The basic idea is they assume all the data they have belong to class Y. The goal is to identify those clusters in an unsupervised manner. Then with the physics data points added, they run a decision tree algorithm to partition the spaces. The reason this works is if there are indeed clusters in our original data, it cannot uniformly distributed. So by adding the fixtures data points, we can identify the true clusters we need, because within those clusters, the number of Y points will be more than the fixtures points. Now let's have a look at which is more robust to noisy data, a decision tree or naive Bayes. Naive Bayes is computationally faster than decision tree. Volume versus noise. I would recommend the naive Bayes through the decision tree fitting and training process may take you longer than naive Bayes. If your data is small, naive Bayes can achieve reasonable performance too and would be straightforward to implement. How much data do you have on hand, how sparse, etc. Now let's have a look at what's a simple explanation of entropy as used in decision tree. The idea of entropy is to quantify the uncertainty of the probability distribution with respect to the possible classification classes. For example, imagine you have two classes, A and B. Probability of A is equals to 0.5 and probability of B is equals to 0.5. The distribution of probability of A and probability of B would have high entropy because there is an even split between the possibilities. In contrast, probability A equals to 0.9 and probability B is equals to 0.1 would have lower entropy because it's much more likely to be a class A and B. Once you understand entropy, the decision tree explanation is straightforward. Decision trees compute what it's called an information gain. The idea being that you can quantify uncertainty about your current classification accuracy. You can also reason about what node you should add next in the decision tree to maximize reduction of the uncertainty. Now let's have a look at when would you use random forest over gradient boosted machine GBMS. So algorithmic difference is random forests are trained with random sample of data, even more randomized cases available like feature randomization, and it trusts randomization to have beta generalization performance on out of train set. On the other spectrum, gradient boosted trees algorithm additionally tries to find optimal linear combination of trees. Assume final model is a weighted sum of prediction of individual trees in relation to give trained data. This extra tuning might be deemed as a difference. Note that there are many variations of those algorithms as well. Now let's have a look at how do you correct for overfitting for a gradient boosted machine. There are many forms of complexity reduction regularization for gradient boosted models that should be tuned via cross validation. The most general ones include use of a shrinkage factor or learning rate applied to the contribution of each base learner. Smaller values can help a lot. Careful selection of an appropriate number of base learner usually increase as learning rate decreases. Row sampling of the training data at each gradient iteration, stochastic gradient boosting. Now let's have a look at what are the advantages or disadvantages of using gradient boosting over random forest. Random forest train each tree independently using a random sample of the data. This randomness helps to make the model more robust than a single decision tree and less likely to overfit on the training data. There are typically two parameters in random forest: number of trees and number of features to be selected at each node. Now, the gradient boosting build trees on add time, where each new tree helps to correct errors made by previously trained tree. With each tree added, the model becomes even more expressive. There are typically three parameters: number of trees, depth of trees, learning rate, and each tree's building generally shallow. Now let's have a look at when is the random forest better than decision tree. Decision tree, the output is easy to understand, which is very important in many applications, especially if you are trying to understand your inferences. Structurally unstable, not robust. Small changes in training data can lead to significant changes in the structure of the trees and different prediction for same validation. Examples. Note, there are some ways to improve the stability of the traditional decision trees by using Bootstrap. The method and opposed to output is easy to understand and explain. People don't like using stuff they don't understand. It's always a challenge to explain to customers why they should spend their $10 million advertising budget in a certain way because a random forest says so. Computational less expensive than a random forest. Now comes the random forest. It's really difficult to understand what 1,000 random forests are saying. Robust doesn't suffer the instability problems of decision tree. The method is harder to explain and understand for a layperson. Computationally can be very expensive. Now let's have a look at why it's recommended not to prune the trees while training random forest. A decision tree that is very deep or full of depth tend to learn the noise in the data. They overfeed to the data, leading to low bias but high variance. Pruning is a suitable approach used in decision trees to reduce overfeeding. However, generally random forest would give good performance with full depth, as random forest training use bootstrap aggregation or sampling with replacement along with random selection of feature for a split. The correlation between the trees or weak learners would be low. That means although individual trees would have high variance, but the assembled output will be appropriate. Lower variance and lower bias because the trees are not correlated. Now let's have a look at how to explain decision tree and random forest in layman's terms. Decision trees look at a primary features. They may give us insights on a response, then splits it. Let's say you want to predict whether a patient entering an year is high risk or not. A decision tree may show us that we should first consider whether they are over 50 years old. The first split on side for over, another for under. Given yes, we may consider if their blood pressure over 150, first split on BP branch. Give no, we may instead look at the other vitals or give another range of BP. We continue our split down to the branches until we reach our responses, high risk or not. For example, on a single branch, we may end up with something like if age over 50, BP over 150, temperature above 100 Fahrenheit, then the patient is high risk. Then that's a decision tree, very interpretive but not much predictive power all alone. Random forest uses a lot of decision trees, say an ensemble, where each tree a little bit different from the others. When we get a new patient, we take a majority vote of the ensemble to get a final result. Now let's have a look at how does randomization in random forest work. Random forest employs randomization in two places. Each tree is trained under using a random sample with replacement from training set. When training individual trees, random subset of feature are used for searching for splits. This can reduce the correlation among trees in the random forest, which improves the predictive performance. Now let's have a look at what is the out-of-bag error in random forest. What does it mean? What's a typical value, if any? Why would it be higher or lower than a typical value? Random forest technique involves sampling of the input data with replacement, that is bootstrap sampling. In this sampling, about 1/3 of the data is not used for training and can be used for testing. These are called the out-of-bag samples. Error estimated on this out-of-bag sample is out-of-bag error. Now let's have a look at when should you not use random forest. A few cases are rather obvious. When a linear model is obviously, you do check your data by plotting it before you apply any algorithm, right? The better route. When you have a lot of or a few informational high cardinality categorical variables, most random forest implementation deal with this kind of variable very poorly. You can also use a random forest as the mean function of the time series prediction. See the last point in this answer and its sub point. Now let's have a look at, can you deal with missing values in random forest? Before you replace or remove the missing values, you need to know why you have this missing value. Where, when, how. What is the influence, how many are missing? Then you come up with the next step, unsupervised solution. You could replace the missing with the following. You could decide which one makes more sense, depends on your research, why you have this data missing. Then comes mean, median, and then 0, the values you estimated for regression or clustering, linear regression, KNN or so. And there comes a supervised solution. For example, a variable like AGE, you cut your income value into several segmentation by distribution or your experience or by algorithm based optimal splitting. Now let's have a look at, is random forest a viable model for image classification? Theoretically, yes. Practically, not so much. Why? Because you need to do feature extraction somehow. Unless you want your model to be completely static, which you probably don't. The feature set will need to grow. That means that you have to automate it somehow. The best way to automate image feature extraction and most other data types too is to use some form of representation learning, of which deep neural network are hands down easiest. It's kind of difficult to write an actual random forest that's efficient in your average deep learning framework, just because of the way that both random forest and deep neural network work. So in this tutorial, we have learned about what are the basic data science interview questions you need to learn. And if you want to get updated with the new advanced level of data science, and if you want to do courses on this, then please go to Great Learning Academy, where you will get almost 80 plus free courses, that too also related to this domains, right? So please go to Great Learning and do your courses accordingly and claim your certificate for free of cost. And if you want to do these courses in your Great Learning application, the mobile app, you can do as well. Right? I hope this video helped you to understand what are the basic questions you need to have a proper idea if you want to change your domain and if you want to start your domain in data science. So please like and subscribe Great Learning to get updated with the new content, and also do let us know in the comment how you feel about the video. Thank you so much.